Yes.
Yeah, great. If I speak too fast or you don't understand anything, just shout and I'll just repeat. So this is a workshop on deploying Hyperledger Fabric with Kubernetes and Helm. I'm Sasha. I'm the CTO and Chief Data Scientist at ATEC, and this is Nicola, lead blockchain engineer, and we'll be happy to answer your questions if you have any. If you get stuck, just ping us. So as I mentioned before you start, you want to ideally, if you want to follow along now, to set up a Kubernetes cluster in the cloud, ideally not MiniCube, and we'll explain later why. To get a domain name for your cluster, either on something like Namecheap or GoDaddy or whatever, or something for free. And make sure that you have our repository, because we'll be using files from there. So a little bit about ourselves. So I try and deploy and develop blockchain solutions that can be easily deployed on the cloud by using Kubernetes and Helm. And I used to be a cognitive neuroscientist, and I've gotten some awards on like writing stuff. And Nicola, maybe you can describe yourself.
Okay, sure. Hello everyone. I'm Nicola. I'm a lead blockchain developer at ATEC. I mostly focus on developing the application, and I've been using Hyperledger for 1 year and a half now. And yeah, I made some contribution, same as Sasha, to the Hyperledger code base. I'm more on the Composer one on my side and Fabric. And yeah, that's it.
Thank you, Nicola. Okay, so since you're on this conference, you all know what blockchain is, so I don't think I need to repeat myself, but basically it's a way of establishing trust in a shared record of events between participants in a way that this is distributed and, funnily enough, trustless. I'll just briefly touch on what we do at ATEC. At ATEC, we develop a platform for doing donations, charitable remittances, and other types of value transfer to enable disempowered and disenfranchised people to obtain goods and services. And we follow the sustainable development goals. That's what the things that guide us in our mission. And if you want to find out a bit more about our product, we can talk afterwards. I'll also note that we are hiring for a bunch of technical roles like front-end, back-end, other blockchain engineers, and DevOps. But without more ado, let's actually start. So we're going to split this workshop into 4 sections. The first section will just talk a little bit about Hyperledger Fabric for anyone who is not that familiar with it. For example, if you've been working with Kubernetes, but you haven't worked that much with Fabric. In the second section, we'll talk about Kubernetes for any one of you who might be familiar with Fabric, but not with Kubernetes. And the third section will be the largest piece. It will span these 3 hours. And we'll be deploying, firstly, a very basic development network in Fabric with one peer, one order. And then a production deployment in the second half, where we'll have actually certificate authority, an ordering service using Kafka, consensus, and several peers. And at the very end, we'll just discuss next steps, and we'll have time for questions and so on. So yeah, so this is what the actual clusters are going to look like. On the left, you have the development cluster with just a single order and a single peer we bound to a channel with the CouchDB database. And on the right, you have a more production-ready deployment with a certificate authority, a Kafka cluster with several orders mounted. It doesn't have to be 2, it can be more easily. But in this example, because we have limited time, we just deploy 2. But it's really easy to actually add more. And then 2 peers, again bound to the same channel, and again with CouchDB on them. So the code, as I mentioned, you can download it from here, github.com, atechnology, hgf-kts-workshop. And as we mentioned, we don't recommend using MiniCube here. So for one, it can be tricky to set up. For 2, the bandwidth here, because if we were all using MiniCube, we'd have all to download separately the images for Fabric, for the Order, for the CA, for Kafka, for Zookeeper, for the CouchDB, and that would be a massive drain on the network. And I don't think I'm as much confidence as I have in the organization here. I think it might be too much for the Wi-Fi system. And the last reason is that MiniCube is not production. Ideally, we want to be able to deploy Kubernetes in production and might as well start with a real cluster on the cloud or on premises if you just are connecting to one of your on-premises Kubernetes clusters. But at least you wanted to have several nodes. Which cloud? We've been asked which cloud as well. Actually, you should not care. That's kind of the point of Kubernetes. Kubernetes is a system to enable to be essentially cloud agnostic or even have clusters on premises. You can use Amazon Web Services. They have a managed Kubernetes cloud. Google Cloud Platform also have one. Microsoft Azure have one. IBM Cloud, DigitalOcean, and so on and so forth. Choose the one that gives you nice credits and that you feel comfortable working with. That's the most important thing. If you are using Azure, as we are, we're going to do a cluster quick start. So I'm going to actually get to my terminal, and we're going to follow these steps together. So I'm just going to export a group. So this is a resource group on Azure, which is basically just a container for different resources to be kept together. We'll only deploy one resource, which will be the Kubernetes cluster. So, and I use a location that is close to me, so I can talk to it easily. Okay, create. So we're going to create the cluster now, so that you can actually, and that's going to take a while. The group actually will be more or less instantaneous, and then I'll just create the cluster. Create, there we go. G group. I'll just call my Kubernetes cluster the same name as I use my group, but you can actually use anything that you like. You could call it, I don't know. And I'll use some standard DS2 images, which basically are just some virtual machines with 7 gigs of RAM, which should be enough for the Kafka. And I'll just use the latest Kubernetes version that is available on Azure. But if you're on Google Cloud Platform, you might have a different one. If you're on AWS, you might have a different one. And I'll add 5 nodes so that we have enough for the Kafka. If you are using, for example, for some of the offerings, you might be using, for example, the free Azure offering, and then you might be limited on how many nodes you are able to create. If you cannot create 5 nodes, that's fine. We'll talk about how to kind of bypass that for this workshop. But ideally, in a real production environment, you'll have at least 5 nodes. And that's going to run for the time being. So I'm going to forget that, and we're going to get it back to the presentation. Because the Kubernetes cluster will take a little bit of time to actually deploy. So let's talk about Hyperledger Fabric. For those of you who don't know about it, who here has worked with Hyperledger Fabric? Maybe a show of hands. Okay, so maybe half of you. Okay, so let's talk about Hyperledger Fabric a little bit. Some of you will know that Fabric is a framework under the Hyperledger project. The Hyperledger project has a number of frameworks like Sawtooth, Iroha, Indy, Barrow, and so forth. And Hyperledger Fabric allows you to build permissioned blockchain networks. You can look at this website, read the docs. It has a lot of documentation. It's pretty good. I'll touch on the core aspects of Hyperledger Fabric. In there you will have 3 types of nodes that will be deployed in production. The first one is the certificate authority. In fact, you don't necessarily need to use the Fabric certificate authority. The Fabric framework is quite modular, so you can use any certificate authority that you want. But the Fabric certificate authority is pretty good, so this is what we'll use in this presentation. It allows you to register and enroll identities. So this will allow you to obtain the crypto material that you need for your orders and peers to run. The ordering service is what provides the consensus. Even in development, you have the solo order, where you just have a single order that just packages transactions and puts them into blocks and then sends them to the peers. And in production, you have a Kafka network that establishes some consensus that is crash fault tolerant, not yet Byzantine fault tolerant, but I'm quite sure that the Fabric is actually working on a Byzantine fault tolerant system. And we also have Alison here who deployed BFT Smart, and so you actually can also use his system. Then there's the Fabric peer, which actually maintains the blockchain and communicates to the ordering service to actually send it transactions to be packaged, and then receives back blocks from the ordering service. Right. The Fabric CA, as I mentioned, it manages the identities. It first registers the identities. This either you can register the identity name and the password, or it actually you can just register the identity name and get a password back that is self-generated by the CA. This ends up issuing e-certificates. And then you can renew these certificates or even revoke them, although the revocation system on the CA is not enforced for now, but it's something in progress, I think. The ordering service, as we mentioned, it consists of a set of ordering nodes, either one for development with the solo, or as few as 2 or as many as, I don't know, like 100 for Kafka cluster. And the Kafka cluster, there is actually a walkthrough on how to bring up a Kafka cluster, and this is where the information was taken to actually set up the Kafka cluster in Kubernetes. If you were doing it by hand, it would be quite a lot of work because you'd have to set up at least 4 Kafka nodes and at least 3 Zookeeper nodes, but Kubernetes allows you to do that in a single command. And then there's the peers. They are the actual nodes that store and maintain the blockchain ledger. They do it typically on disk, but they can also attach a CouchDB database to allow you to hold and query the actual current world state, not the entire blockchain, but what is now in the blockchain or world state, which allows you to do rich queries and actually do some kind of better analytics than if you had to kind of query all the blocks and then recompose them by yourself. Okay, I'm going to get some water. Cool, so Kubernetes. Who in the room has actually worked with Kubernetes before? Okay, so a minority, so there's more, yeah. Okay, so Kubernetes is basically a system for orchestrating the deployment and management of containers. These containers are typically Docker containers, but in principle they can be, they should be any kind of Linux containers. And are you guys, who is at least familiar with Docker and Linux containers? Okay, so quite a lot of you. Basically, a container is just almost like a shell where you can run an application inside. It ensures that the application inside the container doesn't only have access to specific system resources, specific system files, specific allocations, and that it does not interfere with other processes on the same machine. And that allows you to, for example, package completely different libraries into one container, running alongside another container that has a completely different set of other libraries, and they cannot actually interfere with each other or mess around with each other's storage and so on. So to work with Kubernetes, we need to understand like 3 core concepts. There's the Kubernetes cluster, that is basically a set of machines that are connected together through a Kubernetes master. And it manages a set of abstractions that allow us to orchestrate containers much more easily. Because working with raw Docker, it's kind of quite difficult, especially if you want to do it in production. Then we can think about the charts. So the charts are packages that group together different Kubernetes components into templates. So these act as cookie cutters for different applications that you might want to install. You might have a Helm chart for a Postgres database, and you can just click install, and then you have a Postgres database running on your cluster without having to deploy separately different components like deployments, services, ingress, and so on. And Helm is the actual tool, together with a server-side tiller, that actually allows us to install charts. In the future, actually, Helm will probably change and become a client only, so it won't actually need tiller, but currently in version 2, you need to have a server-side tiller code helping you do all that stuff. And basically, the good thing about Kubernetes is that it allows us to group resources, deploy containers, scale the number of containers either manually or automatically, self-heal. So when we talk about self-healing, basically if one of your containers dies, then Kubernetes notices, oh, this container died, so let's actually restart it on a different machine, because maybe one of your servers got hit by a meteorite, and you need to kind of keep your nice little application alive. And it also allows you to connect to these containers, either within the cluster, so it manages kind of internal domain name service, IP, kind of internal IPs, but also from outside the cluster using constructs called ingresses. And it basically orchestrates, and it really, this relates quite, this is from the Kubernetes blog. It's about the principles of container-based application design, and it's very similar to the 12-factor app. Do you guys, I guess some of you guys might be familiar, yeah. Some notes, that's all good. And there's charts. So we talk about charts, they're bundles of templates that define Kubernetes components. KubeApps Hub actually has some, and I'm just showing off some of the charts that we created for the Hyperledger Fabric deployment. So there's the HLFCA, the CouchDB, kind of half hidden in there is the HLF Orderer and the HLF Peer. And those are all available, and actually they're at version 1.3 now. We already updated them 1.3, and we'll be updating them with 1.4 quite soon, once we test them. And Helm, yes, it allows you to package, and you can actually, it allows you to also create Helm charts as well, so you can create a package and then modify it to fit the needs of your application. And yeah, Tiller manages the server-side stuff on the actual cluster. Okay, so I think that my, okay, where are you? I think that my cluster is still being created. Okay. I guess since the cluster is still being created, we can just get a different cluster for now, if we like. Maybe I can just get one. Basically my developer cluster. I'll just go into here. Basically, you can just get the credentials to your cluster. If you exported the group and location, you can do something like AZ, AKS, get credentials of your group. So it might be, for example, HGF, workshop, and then, for example, HGF, workshop, AKS. So this would be the actual credentials. Okay, that's fine. Okay, so it's actually kubectl, get pods, let's see. No, it doesn't like it because it's not finished creating, I think, the cluster. Oh, never mind. We'll get there. I'll just get back to my original development cluster, and we'll just go from there. Okay. One of the things that you want to do is to install Helm. And to install Helm, we're going to actually use the file that we have in our repository. Master, GitHub. Yeah, fine. Okay, anyway, we have the Helm RBAC. kubectl, create -f helm rbag.yaml. That will create essentially an rbag profile for our tiller. In my cluster now it already exists, so we don't need to create it. And then I will actually initialize our Helm with the service account. If you're using a Kubernetes cluster that doesn't support RBAC, you don't actually need the tiller part, so you can just do Helm in it. And that will also work. But if you're using RBAC like on AWS, Azure, then you will definitely need those commands. So let's look at what we have in our Helm list. Okay, we have a bunch of different things: Cert Manager, Prometheus, and PostgreSQL for Grafana. So okay, it's all quite clean. So we can get there. Okay. So I'm going to minimize this for now again. So as we mentioned, the basic development cluster that we're going to work on now is going to just have three components. The order itself, the CouchDB, that will be part of the peer, and the peer itself, which will be bound to a channel. So the order will be running solo, so it will be basically no consensus, just be packaging blocks. And the peer will be just maintaining the ledger and the channel. The first thing that we need to do is to actually set up the cryptographic material. And to set up the cryptographic material, we need to get CryptoGen. So I think that quite a lot of you have Macs, a few of you have Windows, so there's two ways of installing. If you have Mac, you can use Homebrew. That's probably the easiest thing. We created a few tabs on our repository, they're open source, so that you can basically download them by running brew tab 8technology/Homebrew Fabric, and then brew install Fabric tools at 1.3.0. So this will give you the latest tools. We have also versions for 1.2 and 1.1, but in this presentation we'll work with 1.3. And if you're on Windows or on Linux, you probably will want to just use this command with curl. This is the official kind of standard way on the Fabric docs to get these Fabric tools. It will basically download for you the CryptoGen, config.txgen, and a few other tools that are used for Fabric. And you just need to specify the version, which is 1.3. Are you guys all there? Do you guys need me to wait until I get to the next slide, or?
It's downloading.
It's downloading, okay. Okay.
Well, slide available somewhere?
Sorry?
Do you have this slide available somewhere?
A little bit louder, sorry.
Do you have these slides available somewhere?
Oh yes, all the slides are available through the SCED, so through the official Hyperledger global forum. So if you go to the actual session in the schedule, you'll be able to download the slides, so you can actually have them at your side. So once you have CryptoGen, we can actually create the development materials. So, okay, let's actually cd to the dev example first, and we'll cd to config. Actually, so I'm just going to delete the old crypto configuration, right?
Well, the commands are also available on the repository.
Yeah. So I'm going to maximize that and.
The link to the repository is available on the description as well.
Okay, there we go. Okay, so now you can see both of them. So I've cd'd into this directory inside my repository, into dev examples config, and I'm going to use the command CryptoGen generate, and just use the crypto config file that is there. what might actually help is if I actually show you the crypto config so that you, the guys who have not worked with Fabric, you can see what it looks like. And I'm just going to make that a little bit bigger. Editor. Size 30. Okay, there we go. Is that visible enough for you guys? Is that right? So here you basically in the crypto config you can define the order organizations, for example the order, and give it a domain. Because we're working with the Kubernetes DNS, we have this essentially internal domain name service, and the cluster local is essentially your cluster. This points to the services, and this points to your order's namespace in Kubernetes. And the actual host name will be ord1-hlf-ord, because this will be the name of your order, and this is the name of the actual chart that we'll be installing. The same thing happens with the peers, right? So we'll call our peer organization org1, and we'll have a domain peers, service, cluster, local. Again, the actual host name will be peer1 hlf peer. So that's that bit. So we can actually use something like tree to look at the crypto config folder, and you can see that a bunch of different keys and certificates have been created.
Where is CryptoGen located? There's no binary.
The binary is the one that we installed just now. It should have been installed with if you are using if you're using not a Mac, then it will have downloaded it. So you may need to point to it directly. So you may need to actually look at where it actually downloaded the folder with the Fabric samples and so on. And in one of the binary folders, it will be. Maybe I can. Yeah. Does anyone else have trouble finding the CryptoGen binary, or do you all have it?
Fabric samples bin.
Yeah, it should be in the. It should probably be in the Fabric samples or in Fabric tools.
Yes, Fabric samples bin.
Okay, perfect, fantastic. So it's in Fabric samples bin. Thank you very much. Okay. So once you have that, you can actually. We're going to actually create some Kubernetes namespaces, because otherwise some of the stuff will not work. So we will actually create a namespace which is called NS, and the namespace is going to be called Orderers. Orderers. There we go. In my case, it already exists again, and we'll create a namespace for the peers. In my case, it already exists, but for you guys, it will probably not. So the next thing that we're going to do is to actually save the order material to Kubernetes. We're going to define this MSP there. So it's going to be at cryptoconfig/order organizations, order service cluster local, users, admin, because this is the admin crypto materials, MSP. So we're going to define that as an environmental variable so that we don't need to type that 1,000 million times. So we're just going to get youselves to go into that MSP there. Whoops. Admin certs star.pem, and you can actually see that org cert, it actually found the real file. There you go. So we can actually, the next thing we're going to do is we're going to create a Kubernetes secret. A Kubernetes secret is essentially a component, a abstraction in Kubernetes to hold data that your different pods, your containers can access in that particular namespace. So we'll just use kubectl, create secret generic -n orderers hlf ord admin cert. So that's the name of my secret, hlf ord admin cert. And we're going to actually get a file. We're going to, inside the secret is going to be called cert.pem. And we're going to just reference ord cert. There we go. And our secret is created. And basically we can do this more or less the same thing with CA certs. So export CA cert equals ls msp there CA certs star.pem there. And again we can also echo it if we want to actually see that it's actually a real file. And we can do kubectl create. It's not going to be the admin cert, it's going to be the CA cert. And it's going to be the CA cert, and it's going to be the CA cert. There we go. That looks fine. So the next thing is we're going to basically do the same thing with the peer. So again, we're going to do MSP dir equals dot cryptoconfig slash peer organizations, in this case, peers, users, admin, MSP, org, cert, okay, cert equals ls MSP dir admin certs star.pem kubectl create secret generic -n in the peers namespace hlf peer admin cert. And again from file equals cert.pem equals org cert. And org key equals, and actually to not bore you too much, I'm going to actually just copy paste them from the presentation. So we're just going to actually, oops. I'm going to just copy these guys and create them. So we create an organization key, we create a generic secret in peers, and then the CA certs again. And there we have our secrets created. So that's the crypto material, that's the most hassly bit.
So quick question, is this taking the certs generated by CryptoGen and copying them up to the Cube or the Kubernetes?
Exactly, that's exactly what it's doing. Yeah. So now that we have it, we can just quickly go through the actual config.tx that we have in the repository. We basically defined in this, because it's a very basic example, we defined just two organizations. An order organization, which has the MSP dir located here in cryptoconfig, order organizations, order service cluster local, MSP. And then we also define a peer organization, which we call ATEC, and it's located here in cryptoconfig, peer organizations, peers.service.cluster, local MSP. And we define an anchor peer for this peer organization. For the orders, we actually define a solo order. So here's the solo order, and it's again has the domain name of our internal to our cluster, so order service cluster local, and the name of the actual service that we will deploy once we install the Helm chart. And these are some of the typical Fabric options for the actual batch size, the message size, and so on. And finally, we have, of course, the profiles. We have two profiles because we need to create a Genesis block for the orders, and we need to create at least one channel for the peers. So here we just call it my channel. right. Okay. So this is the last bit of this section. So we need to actually create a Genesis block. So we can actually, when we download the CryptoGen, we also downloaded the config.tsgen. So we actually are going to use this tool, config.tsgen profile, order Genesis output block, and we save it to a file called Genesis block. There we go. So we just wrote out the Genesis block. Let's do the same stuff with the channel transaction. So again, we have config.tsgen. We set the profile to be my channel. The channel ID will be called also my channel. And then we'll output and create the channel transaction to a file called mychannel.tx. And that saves the channel transaction. So we're in business. And now we're actually going to save them to our Kubernetes cluster. Again, we're going to create a generic secret. And for the Genesis block, we're going to put it in the same namespace as we'll have our order admin material and eventually also our orders. So they're in different space and namespace than the peer. So there, the secret has been created. It's called HLF Genesis. And it's just from this Genesis file. And for the actual channel, we'll again create a generic secret. In this case, we'll save it to the peer's namespace and call the secret HLF channel and use and get the file from mychannel.tx that we created just earlier.
So,
Yep.
why do you put the Genesis block in a secret?
No, we could. So we could actually probably put in a config map as well, but for now we've decided to put them in secrets, just for.
But can you put in like a normal any folder of the memory or?
You could do that as well. That's also an option. But what I found, I have preferred to use secrets, because then you can actually control with more precision who actually has access to them. And secret you cannot is essentially immutable. So you can delete it if you have access to it, but you cannot change it in place as you would with a mounted NFS folder. So that's why we've gone for that option, basically. So now we've gone through probably the most difficult part of the whole first part of the workshop, which is just creating all the crypto material. The second part is to actually create the order. So this will have two parts, which will be to save the order ID to the Kubernetes and to install the actual chart. So as we use CryptoGen, we did not only create the material for the order and peer administrators, but we also created crypto material for the actual order node and the peer node. So again, we can just get this MSP data. So again, it's in crypto config, order organizations, orders, service cluster local, orders. So instead of being in admins, it's in orders, and then ord1, HLF, and so on and so forth, /MSP, membership service provider. So now we're going to actually get the certificate. So we're going to get the MSP there and get that node cert. So we can actually look at it again, node cert. We can see that it's a real file here. We can actually, for example, let's actually cut it so that you can actually see what it looks like. So it's just certificates. You've probably all seen before. And we can again create a secret. This secret we'll create in the order namespace. Again, kubectl create secret generic namespace orders, and we'll call it hlf-ord1-id cert, and we'll call it inside the secret cert.pem. Oops. And we'll get the environmental variable node cert to actually set it. There we go. So the cert has been created, and we can do the same with the node key, right? So we can get the node key, echo node key, and you can see that it's a real file, and we can actually cut it and show you this top high secret private key. that will be part of the order. And we again can create a generic secret in the namespace orders, call it hlf ord1 id key, and get it from the file that we just got. So now we have everything we need to actually deploy the order itself, right? So we can actually run helm install. So we're going to run this command, right? Paste without new line. So the Helm works in the following way. Helm has subcommands like install. We then specify the repository from which we want to install it. So the stable repository is the main Helm repository that exists. We give it a name of ord1, and we put it in the namespace orderers. And we specify a values file, which I'll show you just next, after we run this command, so that you understand what are the definitions that we'll have. And I'll also show you the chart itself. So the file is going to be just above the config, so it's going to be in dev example, helm values / ord1.yaml. So we run that, and that's going to install our beautiful Helm chart. So just to show you a little bit what are the things that get installed. There's a config map, there's a persistent volume claim, there's a service, there's a deployment, and there's a pod. And the pod contains the actual container. And this for now is pending, and we'll check with it again in a moment. Okay. So we referenced the file just now, right? And the file that we referenced was this ord1.yaml file. Here we have an image tag, so we are using Fabric version 1.3. So you can change that if, in principle, eventually, if you want to use another version like 1.2 or 1.1. But for the purpose of this workshop, we'll stay with that. We also specify some persistence. So we specify that we'll have an access mode of read-write once and the size of 1 gigabyte. This is fine for the development environment. You don't need a lot of space, but in production you definitely want a lot more than just 1 gigabyte. Otherwise, your network is going to run out of space pretty darn fast. We also specify that we're using a solo order, right? And we also specify the membership service provider ID, which is order MSP. And finally, we specify some of the secrets. So we created a few of the secrets just now. So the cert and the key for this order. We also before, in the previous section, we created the certificate authority certificate as a secret. And we created also the Genesis secret from the Genesis block, as well as the admin certificate for the order. So all of these are referenced here, and they'll be used by the chart to automatically set up the order correctly, so that you don't have to copy and paste like particular files into your order container, which would be a nightmare. Okay, so let's check now. The next thing that I want to check is the charts. So we're going to go to our add charts repository, and I can actually show you what the order chart looks like, so that you have a little bit of an idea of what it's like. And I'm actually going to make a bit of a zoom because I think it's quite difficult to see from down there. So let's actually zoom in. Control++. Is that right for everyone? Can you all guys see? Or do you want me to make it a little bit bigger? Do up if you want it to be bigger. Okay, that's all right. Okay. The first thing that you can find in the chart is the chart.yaml. You see that it has some kind of meta information. This is an order chart. They were created by us, and they're currently not directly associated with the Hyperledger project, although we hopefully eventually will make them official. They have some keywords, some application version. In this case, we support Fabric 1.3, and these are the maintainers. That's myself and Nicola, and maybe Nico. The other thing that you want to take care and look at is the values file. So this is the default values file. The values file that we used in the installation is the one that we used to override specific values in this default values file. And here we actually specify like persistence, we specify whether we use TLS, which secrets we use, resources, node selection, tolerations, and affinity, and all the kind of Kubernetes specific things. We'll bit by bit go over them, but I don't want to overload you now with too much information. And usually, there is a hopefully helpful README. So this is a README that explains how the chart works and all the different options that are available in it and what they stand for and what their defaults. And now to the most important part of the chart is the actual templates. So the charts use Go templates to enable you to create essentially manifests that are specific to your use case. So you might have a config map, for example, and this config map has a lot of the order environmental variables specified that we're going to use. For example, it specifies where the Genesis block lives, what the actual consensus type is. Where is the consensus? Order type, so that's the consensus type, whether it's Solo or Kafka, the ID of the MSP, and so on and so forth. We have the deployment, which is this essentially a component that deploys the pods, which host the containers, the Docker containers. And this tells you how many replicas. Typically you'll have one because you'll anyway have multiple orders running alongside and providing resilience to the network. But also it specifies a bunch of secrets that are going to be mounted onto the container. The container port and also the name of the container, the image that we use, so the repository and tag, and the pull policy. Some liveness and readiness probes so that the Nginx can check whether these guys are alive, and Kubernetes can check that these guys are alive and tell you if there's some problems, and some commands to actually start the order here. And then we actually get some environmental variables from the secret reference that we have in the values and from the config map. And we mount some of the volumes as files. So we mount the Genesis block, the certificates, the keys, and so on and so forth. We also have an ingress, which allows you, if you want to actually access the order from outside the Kubernetes cluster via a domain name. A persistent volume claim, which operationalizes the storage. So you actually define what kind of storage you want and how large the storage should be. And that creates this manifest. And the service, which allows you to communicate with the pod and the container inside the cluster. So this is basically the chart. And let's check out how our Helm chart is doing. Is it still live? Let's actually get the order pod. So we installed it. And we can get the pod container name by running kubectl get pods namespace orders. We specify a label, so we want the application to be HLF ord, which is the name of the chart, and the release to be ord1, which is the name of this particular deployment, of this particular release. And we output, using JSON path, we output the name. So basically you end up with something like this. Echo ord pod is this one. You can also, if you want, you can just copy paste it from here as well. Okay. And then kubectl logs. So let's just copy this guy. So we're going to get the logs for this order and check that starting order has started. And the order has started. I'm just going to show you what the logs look like so that you can see that you can get all the logs that have been created. There you go. So you can see that it's running order pod. And now we can actually get to the Fabric peer. So this is the last part of this half workshop. we're going to do 5 steps. We're going to install the CouchDB, Helm chart. We're going to save the peer ID that we created from CryptoGen onto Kubernetes. We're then going to install the peer Helm chart in a very similar way as we installed the Orderer Helm chart. We'll create a channel and then fetch and join it, just as we would in a kind of in local Fabric network on your computer. So the first thing that we'll do is we're going to install the CouchDB. Again, we run the Helm install command, use the stable repository HLF CouchDB. We'll call it cdb-peer1 and specify that it will be in the namespace peers. And again, we'll specify a specific values file to override the default values of this Helm chart. And I'll show you again what this, so again, you can see that it has a deployment, a pod, a secret, a persistent volume claim, and a service. And this is what the actual values file looks like. We just specify the version of the CouchDB, of the Fabric CouchDB that we want, which in this case is 0.4.10, and the persistent size of 1 GB. Let's go and look at the actual chart so that you get an idea of what it looks like. So the CouchDB chart looks like this. Again, you have the chart with some information. This is the CouchDB instance. Has some keywords and so on. Here's the values file. The values file specifies that we only want 1 replica. And we want to use the repository Hyperledger Fabric CouchDB. And by default, it has a tag in this case of 0.4.9, but we can specify a different tag and then get a different image. We have a service. We can have an ingress if we really want. And some persistence, in which case we just defined 1 GB. And we have, importantly, the CouchDB username. And it auto-generates a random password of 24 characters so that you have a secure connection to the CouchDB. And we'll go back and go to the actual, again, we have README. So, too long didn't read, you can just install it. Basically, and you can see all the different variables that we use and how to set them. For the templates, we have a deployment which deploys the pod and therefore the container that the CouchDB runs in. The ingress, if we want to access the CouchDB from outside. So, for example, you might want to connect to it with some kind of graphical interface so that you can see it. The persistent volume claim, which holds the volume. And importantly, the secret. So here is where we actually auto-create a password if we don't provide one. So you can actually auto-generate a random alphanumeric 24 length password. Or we can specify our own if we want. And finally, the service, which allows us to communicate with CouchDB from inside the cluster. And now that it should be hopefully running. Sorry. We can actually get the CDB pod. Or again, copy-paste it from here. And we can actually get the logs. Oops. And you can see again that the CouchDB is also running. So now we're going to do, just as we did for the order, we're going to save the peer identity to Kubernetes. So we're going to get the MSP dir in the crypto config, peer organizations, peer service cluster local, peers, peer one, and so forth, /MSP. We'll get the certificate. And we'll get the secret and create the secret. Then we'll create a key and create the secret again for the key. Once we've done that, we can just install the peer chart. So there we go. Again, we have a bunch of different components, Kubernetes components like the config map, persistent volume claim, service deployment pod. We can just get this guy. Peer pod, for example, calls that basically. Or you can run this command to get it. And again, we'll see that we have some values files. The important things are, again, we have a tag, so we use Fabric 1.3. We have some persistence defined for read-write once and 1 GB. And we specify that we actually use a database type of CouchDB. In fact, we can, if you don't want to use it, you can just use a LevelDB database and not install the CouchDB chart at all. So that will work as well. And we also specify the name of our CouchDB instance, so it will be cdb-peer1. So that will actually allow our chart, our peer chart, to automatically get the secret from the relevant CouchDB Helm deployment and get the login and the password credentials so it can connect to that CouchDB, so you don't need to manually specify all the CouchDB credentials when you deploy the peer. So that makes it a little bit easier to deploy. We specify also the MSP ID, which is peer MSP. Oops. Again, we specify some secrets like the certificate of the peer, the key of the peer, the certificate, the CA certificate for the peer, and the channel that we created before, the peer admin certificate, and the peer admin key. And again, let's check out the chart for the peer. Again, the key things are basically the values. We basically use the Hyperledger Fabric peer to install it. We specify the service with the port and event requests, an ingress if we want to expose it to the internet, and some persistence, as well as the type of database, whether it's GoLabelDB or CouchDB, as well as gossip configurations, and whether we are wanting to use TLS for it, as well as a bunch of different secrets that relate to the certificates, the TLS, the channel, and the admins. And in the templates, again, you can see a config map, which defines a bunch of different peer environmental variables that are used inside the Docker container, like the listen address and the logging, gossip parameters, TLS parameters, and so on and so forth. Again, the deployment. This is all starting to look familiar to you guys by now. Here, we start the peer, and we do some configuration here, depending on whether we run TLS or not. We have an ingress to connect to it from outside, a persistent volume. That looks very similar to what we had before, and the service to connect to it. And now that we have all that, we can actually check the logs and see that our peer has started. Now that we have a peer that is running, we can actually create a channel. So we can actually run the kubectl exec command here to execute a particular command inside our container. We specify the namespace peers and the peer pod that we are talking to. We run peer channel create. We specify the order we want to talk to, the name of our channel, and the location of the channel file transaction. And we receive the block, basically. Now we just need to fetch the block, again using kubectl exec. Again, we talk to the same peer, and we run peer channel fetch config. We use the block that we got. This is where we will actually download the block. We'll specify our channel and the order that we talk to. And we received the relevant block. Now that we have the block, we can actually join it. kubectl exec and peer, our peer pod again, and then we run this command. We need to run actually bash-c, and the reason for this is that we want to actually specify an environmental variable that exists on the actual container, peer container. So we do not want this to autocomplete to our local environmental variable, and that's why we specify this bash-c. And then we run peer channel join. We specify this MSP config path to point to the admin MSP path, where we have the peer administrator memberships provider materials, and we join it to this block. And boom. And finally, we can run this command to check that peer channel list, to check that our peer has joined the channel. Has joined the channel. Okay, come on. Join the channel. Okay. Let's see. Okay, it already exists. Yeah, so it definitely has joined it. Oh, there we go. You can see it here. We can just also just use grab my channel. There we go. Okay. That is more or less concludes the first part of the workshop. The next thing that if you've been following along on your computer, you can actually delete everything by running this set of commands, because you want to delete the order, the peer, the CouchDB, and also delete the secrets that we created for the orders and for the peers. So we're just going to delete those and delete the secrets. And now you have a clean slate for the next half of the workshop. Full disclosure, we don't actually run these commands by hand at ATEC. We actually have an internal tool that actually orchestrates that for us, and we're actually going to be releasing that later on, probably in a few weeks or perhaps a month. But it's still, we feel it's still useful to actually show all the commands that go into that, so that you understand first the complexity of the deployment, but also so that if something goes wrong with the automatic tool, you can actually understand what is going on wrong and you can actually debug it. So this is why we're kind of going over all these things, of which there are quite a lot, and there's a bit of repetition. So please bear with us. Well, there's a lot of different Helm charts. For the Hyperledger Foundation, there is also a chart for Barrow, For sure, and I think the guys at Sawtooth, I think they also have some Helm charts, but I don't think they released them to the main Helm chart repository. I'm not sure if they've open sourced them or not. In the official Helm charts repository, yes. But at one point IBM had a kind of macro chart to deploy everything on their own repository, but as far as I'm aware, it's not been maintained for about 6 months. The last time I looked. So I don't know what's the status of it now. But we are the ones who maintain these separate Helm charts. And personally, I prefer to maintain separate Helm charts for each component, because then you can compose these components together. Otherwise, if you have a Helm chart that you need to edit to change, create a new network, it's not really useful Helm chart, in my opinion. So, yeah, so you can just go ahead and delete it with that command. And the next section is going to be the production setup. We've been here for just over an hour. So if you have any questions now for the next 25 minutes about the development setup, we can take questions, and then we'll have a break, and then we'll come back and do the production setup. Question?
Does this use the Docker and Docker principle?
Basically, yes. Yeah. Although eventually, as far as I know, the Fabric guys who are working on the Fabric, they want to enable the chain code containers to be also managed eventually by Kubernetes. So that's the ultimate goal. But we're not there yet, I guess. So for now, it's Docker and Docker, yeah. Any more questions? Any parts that you'd like me to go back to like explain in more detail? Because I realize there's quite a lot of different material, and some of the stuff I've kind of glossed over. Any bits that you want to discuss?
How will you deploy chain code in Docker?
Okay, that's a good question. So basically, you can deploy chain code in much the same way as you deploy on a local machine. You can, at the moment, we still haven't. What we want to do is to create a CLI chart so that we can actually easily connect and deploy chain code. For now, we're doing it in a slightly more arduous, more or less manual process. Nicola can tell you a little bit more about it.
Yeah, we're building a connector using the. We're building now a connector using the SDK, the Node SDK, to install and instantiate the chain code on that and to invoke the chain code. So yeah, that probably it's on the roadmap to make easier to get into that part later.
Connector is just a tool, or because you can do both using CLI or the SDK, right? So
exactly.
Yeah, you can do either ways. Yeah. So.
But what is your recommendation?
For now, what I did so far was using the CLI, but I'm trying to build the SDK on top of.
Like management SDK for everything.
Because I don't have the benchmark to say which is the best, but we're getting there. Yeah. So.
Or anyone who has had any trouble with installing anything or deploying any of the parts so far? Maybe we could actually even continue now and like do some of the parts, and then afterwards like get as far as we can until the break, then have the break, and then finish the production, and then we'll have time for one-to-one time with whoever needs help or whoever has questions as well, just to not waste time, and also because we can get more done. Okay. So the next thing that we're going to work on is then the actual production setup, right? So the main difference here is that we're going to use a certificate authority to actually create all the crypto material instead of using CryptoGen. So this will allow us to actually generate it more or less online. Again, the second difference is that we're using Kafka, so we'll need to deploy a Kafka cluster, and hopefully you'll see that that is considerably easier than it sounds. And then we'll just create multiple peers, which will be really, really similar to what we did with creating one peer. There's not much difference there. And in this case, again, we create just 2 orders and 2 peers, but in reality, in a proper production environment, you'll have more, because you want more crash tolerance and more replication generally than just 2. Before we get there, we need to install a couple of more or less almost like standard Kubernetes components. So the first thing is we're going to do is we're going to CD out of our dev example to our prod example. So we're going to do that. So now we're in our prod example. You can see PWD, that's me. So we're going to install an ingress controller. In fact, because I want to show you how I installed the ingress controller, I'm actually, oh wow, interesting. Yeah, so I'll do it actually here, anyway. So basically that's going to install the ingress controller, which is a component that checks incoming requests to the Kubernetes cluster, basically. And when it receives a request, it looks basically at what is the domain name that was asked for, and then it looks at the ingresses that it has that exist on the cluster, and then redirects the request to the correct service and then pod in your cluster. So here we can see that they're being created, and the thing that you want to run is you here have some notes here. So it says the Nginx ingress controller has been installed. It may take a few minutes for the load balancer IP to be available. So you can watch the status by running kubectl namespace ingress controller get services or wide Nginx ingress controller. So let's run that command. Just copy paste it, and we get an external IP. In fact, I'm just going to get my other ingress controller because I already have one installed. So I'm actually going to use a different external IP. Once you have that external IP, you can, for example, go to your domain name registrar, right? And you can be like, okay, let's install some stuff. Okay, let's sign in. Go to my domain name list. Okay, let's add a new record. Oh, that's very small. That's very, very small. I'm sorry.
I'm sorry, Sasha, I got lost in the last couple steps here.
Sorry?
So you did the install of the ingress.
Oops.
And then after that,
yes, with the Helm command. I'll show you it again in one moment. So I'm just going to point this do a wildcard pointer to the ingress controller IP, which will be this one. Oops. So you have it here. And I can just show you the command again that we used to install the Nginx ingress, I guess. So we basically just install Helm install, the stable version of Nginx ingress. I put it in a namespace called Nginx ingress, but some people put it in kube system, which is also completely fine. So I put it in a namespace called ingress controller, and you can give it a name like Nginx ingress, for example. And once you have it installed, you basically can get basically run kubectl namespace, whatever namespace you install your ingress controller, for example, ingress controller, get services wide, and this -w means watch, so it will continue watching until when there's changes. In your case, you might see initially the external IP as pending, so it might take a while until you actually get the IP address for the external IP that you can use with your domain name registrar to specify that you want that domain name to point to the IP of your cluster, basically. Cool. So now that you have that, we can also then install the certificate manager. So the certificate manager actually is a tool. There used to be a thing on Kubernetes called kubelego, and the cert manager essentially allows you to obtain TLS certificates for free automatically, and it will renew them automatically as they expire. So you don't need to do that by hand, basically. And we just, again, install the Helm install stable /cert manager. I'll install it in the namespace cert manager, but again, if you want, you can install it in different namespace, such as kube system. And once we install it, yeah, in fact, I already have it. Helm status cert manager. Let's look at it. It basically just has a single pod running in a deployment with a service account and a cluster role and cluster role binding. And that will take care of all the certificates itself. But before we can use it, we need to actually create some certificate. Let's actually look at this file. We'll need to create some cluster issuers. So the cluster issuer will allow you to deploy TLS keys that are either for staging or for production using Let's Encrypt. So we can essentially install this one, create one. In my case, it's already installed. And the second one for production, we can also create it. And again, in my case, it's already installed. Basically, you can actually, I can show you what the production one looks like. Whoops. Production. It basically has information of which server, which is acme v2 API let'sencrypt.org directory. And you probably want to change the email, because I don't necessarily want to get all your certificate renewal subscriptions. So before you actually run that, you might want to change the email of the production one, because that's the one we'll be using. And it gives it name Let's Encrypt production. Okay, next time I'll add this. Okay, cool. Now that you have it, you will want, for this part of the workshop, you'll want to have access to the homebrew, to the Fabric CA client. If you already installed the previous tools, it should also be in the binaries, again, in the Fabric tools/bin folder. But if you haven't, if you have a Mac, you will want to root up a technology homebrew Fabric CA, which is a different tab for homebrew, and the brew install fabric-ca at 1.3.0. And that will give you the Fabric CA client. And we also have it available for 1.2, 1.1, and I think 1.05. And if you haven't already, you need a domain name, again, to link to your ingress controller. Yeah, you can get one for free or for cheap. We quite like Namecheap because it's easy to use. And yeah, let's get started with Fabric CA. Or we can take a break. We can also take a break now because we've been at it. That will also give your domain name service time to actually correctly link to your IP address. So you can chill out a little bit. Any questions so far?
Where's the email address you said we should change?
It's okay. I'll show you in the actual folder. Okay. Just going to open PyCharm. So it's going to be in the prod example /extra cert manager CI production. So here, that's the one. Basically, you want to change to your email address so that when you actually do a cluster issuing, an issuing of the TLS certificates, so that it specifies your one. And you can also change it in the staging one as well if you want.
You want us to do that for the
Yeah. Okay. So we can reconvene in about 1 hour at 4:40.